But I'd like to welcome you today to the keynote presentation in the defense of preservatives. I am Bob Woodard of LabRoots, and I'll be your moderator for today's event. We are delighted to bring you this educational web seminar presented by LabRoots. For more information, please visit www.labroots.com. I would now like to introduce today's speaker, Stephen Schnittger. Steve is the Vice President of Global Microbiology and Fermentation R&D for the Estée Lauder Companies. He has been with Estée for over 25 years, all with the Microbiology and Fermentation Lab. His primary responsibilities are in the area of cosmetic preservation and advising the chemists on new formulations. Other responsibilities include developing new active ingredients through fermentation, advising manufacturing on cleaning and sanitation procedures, and assisting quality assurance and manufacturing when problems arise. Please join me in welcoming Steve to this presentation. Thank you. I will now turn the presentation over to him.
Good morning. Can you hear me? We had some issues. Good morning. My name is Steve Schnittger, and again, I'm the Chief Microbiologist for Estée Lauder, in charge of preservation and R&D. My other role is looking for new active ingredients and fermentation. And today I'm going to talk about cosmetic preservation. And as you can see in my title, it talks about in defense of preservatives. And you might be asking, why is the word defense in there? And it's because preservatives around the globe are being scrutinized in just about every marketplace from a legal standpoint, a regulatory standpoint, a public perception standpoint. And because of this scrutiny, the number of molecules that we have available for use in cosmetics, pharmaceuticals, the paint industry is being reduced monthly. So it really is a fight and in defense that preservatives are required, they're needed to ensure the stability and the safety of our products. From a mission standpoint, every cosmetic manufacturer, and whether it be cosmetics or pharma, has the dual responsibility relative to the quality of their products. We have to make sure that our products are free from bacteria during manufacturing, during filling, and at the same time, and also once those products are in the hands of the consumer. Many of our products in the industry, in the cosmetic industry, the stability programs go out 3 to 5 years. So we have to ensure that those products will stay free of contamination during the life of that product once in the hands of the consumer. And to achieve that goal, we have to make sure that our products are properly preserved, or that they are properly protected, which might be through protective packaging, and I'll talk about that in a little while. There also has to be a GMP quality program in place, which includes proper environmental monitoring. And these two must go hand in hand, because you could have a formula that was adequately preserved, passed all challenge testing, but if the quality is not there in manufacturing or in the filling operation, then you do run the risk of contamination. Same as if a product was under-preserved, but your quality systems were in place. Because we're not making sterile products or using sterile raw materials, that low level of bacteria may start to grow out because the level of preservation in that formulation is not adequate to kill off that low level of bacteria. So again, these two programs have to go hand in hand to make a quality product. So this is the gist of my discussion today, preservation and product protection. And I talk about aqueous products, that all aqueous products have to be properly preserved because, again, there's water. And where there's water, or moisture, there is that chance of contamination and for bacteria to survive and grow out. Even in a powder, if you had a product that had a high moisture content, there is that chance that bacteria could get in there and become contaminated. And I think this is a good slide, which is indicative of that potential growth. If you had 5 cells at time 0, 5 CFU of E. coli, within 7 hours, it could end up in the tens of millions. And this could happen with any cosmetic pharmaceutical product, whether it be a mascara, a skincare product. If it was not properly preserved, this sort of scenario could easily exist. And this is a good example, too, on why we need proper preservation and proper quality control during manufacturing. Because, again, it could easily grow out into these high numbers. And I think this next slide is even more indicative of the potential of what could happen. And it really is pretty much black and white. On the left side, you have a skincare cream in a wide orifice jar, which is properly preserved. As you can see, there's no bacteria, there's no mold being shown. But on the right side, you have that same cream, which is under-preserved, and clearly there's mold growing on the surface of the product. Pretty much everybody on this call has probably opened up a loaf of bread at one point in time and found one mold spore growing on a slice of bread. And you've thrown that whole loaf of bread out, just from an aesthetic standpoint, thinking that it's not good for you. Well, what do you think would happen if a woman opened up a jar of cream and saw this mold growing on top of their product? They would never go back and buy that cream ever again. You may go back and buy that loaf of bread just saying, oh, it's it's just one slice, but the probability that they would go back to the market, go back to a store and buy this cream ever again, it would probably never happen. So this is why, this example is clearly why we need preservatives or properly preserved products. Product protection is a multifaceted approach. I mean, the main function is through chemical preservatives, and it always will be as long as we continue to develop these sorts of products. And I'll talk about chemical preservatives, those ingredients that are classified and only deliver a preservative activity to a formulation. In the last few years, multifunctional ingredients, or those things that are classified as multifunctionals, have also been used to deliver some form of preservation to a formula. And why they're classified as multifunctionals? Because not only do they have antimicrobial activity, but they also deliver some other attribute like humectancy as a solvent, as a solubilizer, deodorant agent, and I'll talk about each of these different class of products further down in my presentation. Product protection can also come from physiochemical factors such as pH, reduced water activity, manufacturing filling temperatures, which creates an environment which is hostile to microbial growth. For those of you who are familiar with ISO, we've just recently, in the last few years, published a guideline, ISO 29621, which talks about these physiochemical factors, and we've classified a certain list of products which we consider low risk because either the pH is too low or too high, or the water activity is very low, or the fill temperatures are so high that they'll kill off any bacteria that might be present in the formulation. From a cosmetic standpoint, or from an aqueous cosmetic standpoint, these physiochemical factors may play a major role when developing a preservative system, because if you can lower the water activity or the pH low enough, then all you have to worry about is an antifungal. For anhydrous products, they play a major role in determining the level of testing, the level of preservation, and the criteria used to test those certain products. And I'll talk about ISO 29621 further on in my presentation. And finally, packaging. You can fill a product into a package which minimizes the contact between the consumer and the product. You can pretty much make a product that will stay free of bacteria during the life of the product. And again, I'll expand on that further down and talk about ISO 11930. So just to recap this last section, preservatives continue to play the major role, or chemical preservatives continue to play the major role in ensuring that products remain free of bacteria. Multifunctionals, because of the decrease in acceptable preservatives, is playing a larger role, and the multifunctional in combination with preservatives can form a very efficacious formula. Preservative potentiators, again, with the preservatives, are enhancing the activity. The physicochemical factors and packaging all play a role in product protection. I'm going to talk about definitions because I'm going to try to distinguish between preservation, multifunctionals, and potentiators, and show that there is a significant difference between these three different categories of products. And I'll explain why as we go on. Preservation is the process by which a chemical or physical agent prevents a biological deterioration of materials. And this comes out of block disinfection, sterilization, and preservation, which is pretty much the Bible when it comes to disinfection. And in the European Union, a preservative is classified that chemical which is exclusively used or mainly intended to inhibit the development of microorganisms. And this positive list is listed in Annex 5. So if you're marketing a product in Europe, one, it has to have a challenge test to show that it is properly preserved, and two, you have to have a chemical that is on Annex 5, on your ILN or on your ingredient label, to show that it is properly preserved. This is a list that my friend David Steinberg, he has been publishing this list of frequency of use preservatives for 30 years, for as long as I can remember. It comes out every other year. He looks at all the formulas that are registered with the FDA and classifies the different which preservatives are being used. This is both in the United States and Canada. And what I've added to this list in column number 2 is the type of preservative which it is, whether it's a paraben, an isothiazoline, a formaldehyde releaser, halogenated, or organic acid. And as you can see, the preservatives in yellow are those where there's been a significant increase or frequency of use over time. Next slide. Except for benzyl alcohol, which really is a fragrance item, all of these molecules only have one function, and that is preservation. Except for the organic acids, every one of these compounds is under some form of regulatory, environmental, or safety review. Every one of these chemical classifications have some gray cloud over them, which is limiting the use or not giving them a clean bill of health. And because of the restrictions on the parabens, on methyl isothiazoline and chloromethylthiazoline, the use of phenoxyethanol has significantly increased. And only the organic acids, phenoxyethanol and benzyl alcohol, are showing significant increases. Why? Because they don't have that regulatory restriction, or that, I'll call it that gray cloud, hanging over their head. But we, the industry, and whether that's the cosmetic industry, the paint industry, or pharma, cannot survive with only two classes of approved preservatives in our arsenal to help preserve our products. This is the objective of my talk. 15 years ago, if I go back for a second, 15 years ago, every one of these preservatives was used without any restrictions. Formaldehyde releases, parabens, we had a full arsenal of preservatives. But today, like I said, every one of these has some form of limitation. So, we, the global cosmetic industry, we need to make sure that we have a full arsenal. We need to continue to defend these different molecules, find new molecules, and improve the arsenal that we have. Otherwise, we are going to be in some serious issue. Because of the restrictions on many of these mainstream preservatives, multifunctional ingredients, so those things classified as multifunctionals, is picking up the slack. Many companies are using multifunctionals in combination with conventional systems to ensure preservative efficacy and ensuring that their products are adequately preserved. The problem is that many companies, whether they be raw material suppliers or finished good houses, are making preservative-free claims, even though they may contain multifunctional ingredients, or those things, like I said before, which are not on Annex 5 or on the positive list. By doing that, you really are creating issues with not only the companies that are doing it, but also with the industry, because of labeling and regulatory requirements. You're not meeting the requirements which were set down by the European Union to ensure preservative efficacy. So you really do need to have on your label a preservative which is on Annex 5, and you may have in combination with many of these multifunctionals. But the preservative-free claim is not doing anyone giving anyone a clear advantage. I don't know how many people are buying a product because it says paraben-free or preservative-free. Or I've seen where suppliers have put on their label, we don't use dangerous biocides like the other guy. We cannot continue to add fuel to this fire that preservatives are bad, because as I've shown, they clearly are required and needed to ensure that we are making safe products. In 1976, the Seventh Amendment was born, and what it said was that there had to be a recognized challenge test in the dossier, or the documentation that was submitted with that product and that formula into the European Union. And there must be a conventional preservative on that label in combination with that formulation. So these two, again, go hand in hand. There has to be efficacy data, and there has to be an approved preservative. And by only using multifunctionals, you're basically breaking this law. A second reason for using the multifunctionals is there is that potential to reduce the risk of sensitization. As I showed in the frequency of use chart, the amount of phenoxyethanol which is being used in formulation is significantly increasing because of those other broad spectrum preservatives being restricted for use. There was recently a Danish study where they made note that phenoxy is increasing around the world, and they made the claim that there is that potential increase of sensitization. And what I'm trying to prove here is that if you combine the multifunctional with a conventional preservative system, you have the potential of lowering the level of the conventional preservative, plus ensuring preservative efficacy. I wonder if I should take a question. I guess there's nothing on there right now. Many cosmetic ingredients have been recognized as multifunctionals for years, whether they be alcohols, essential oils, EDTA as a chelator, and surfactants. And today I'm going to talk about two which really have become mainstream in the area of preservation. First, I want to talk about glycols. I'm going to talk about butylene glycol a little bit. In the future, I'm going to talk about and also about Caprylyl glycol. But butylene glycol, propylene glycol, has been used in the industry, I think, dating back to the 50s. It was used in the past for improving the solubility of methylparaben, or the parabens. It was used to ensure that the parabens stayed in the water phase and did not migrate into the oil phase. It was used for emulsion stability, especially during freeze-thaw, to ensure that the product was not going to separate. And it was used as a preservative potentiator to deliver that antimicrobial into the cell wall and enhance the killing activity. About 15 years ago, hexylene glycol and penylene glycol were delivered to the marketplace. Again, They were multifunctional. They had moisturizing effect. They had humectant capabilities, and they were also used to stabilize preservatives. The propylene glycol, butylene glycol were used in the past at say 6 to 8%. The hexylene and penylene glycol is now being used at the 1 to 2% range, and now the most recent one is Caprylyl glycol, which has strong antimicrobial activity. It also works as a humectant, a moisturizer, and the level of use is anywhere from 0.5 to 1%. Caprylyl glycol, otherwise known as 1,2-octanediol, it comes in as a waxy substance. It easily melts at room temperature. It has both antimicrobial, moisturizing, and humectant properties. It can also be used as a solubilizer or a delivery system. And the key here is that it does have broad spectrum activity. It really has limited antifungal activity, but it's not impacted by pH. So it works across all product types, against all pH types, and if you combine it with an organic acid, you pretty much do have an ingredient which will kill off bacteria, yeast, and mold. Work that was done by Symrise a number of years ago showed that the Caprylyl glycol will disrupt the cell membrane. It basically will blow open the cell membrane. It's also shown from a synergistic standpoint that it will help lipid-insoluble antimicrobials penetrate the cell wall and kill the bacteria. And the benefit here with the Caprylyl glycol is that it does stay at the water and oil interface between the oil phase and the water phase. It will not migrate into the oil phase, but it stays in the water phase where it's needed, where the bacteria might grow. It's used in combination with just about every conventional preservative system that's out there today, and will boost its activity. It will lower the level of preservation of conventional preservatives that are needed in combination with the Caprylyl glycol, and you get very good activity or efficacy. This is work that we had done in the lab a number of years ago, where we investigated the order of addition when adding the Caprylyl glycol, because many of the chemists they didn't know whether to add it to the oil phase, the water phase, or post-emulsification. And what we did was we tested against the 5 different challenge test pools recognized by the USP. And as you can see up here, we start off with, this is a graph for E. coli. We start off with 10 to the 6 E. coli, and the yellow line is post-emulsification at 45 degrees. The blue line is in the oil phase, and the red line is in the water phase. And as you can see, we went from 10 to the 6 down to about 10 to the 2 within 2 days, and then we had complete kill within 1 week as compared to the oil phase and the water phase. So we showed that by adding a post-emulsification, once the emulsion had been put together, cold at say 45 degrees, we had the quickest rate of kill. And this testing was done for all 5 pools, and pretty much for every case, the post-emulsification worked the best. And as you can see, we did have a 6 log reduction within 1 week. So it is a very good antimicrobial. The next one I want to talk about is ethyl-hexyl-glycerin. Again, it's been used for deodorants. It does have a multifunctional approach. It's both used as an emollient and for its humectancy. It does have synergy with parabens, phenoxyethanol, and isothiazolene, and is also being marketed in that position. This is a very good graph of showing the multifunctional approach and its synergy with phenoxyethanol. So here you have the green line is the ethyl-hexyl-glycerin by itself, and as you can see against Pseudomonas aeruginosa, there is no kill whatsoever. So it pretty much stayed at 10 to the 6 for the 7 days. We then looked at adding 0.9% phenoxyethanol, and it took 24 hours for it to achieve complete kill. But when you combine the 0.1% ethyl-hexyl-glycerin with the 0.9 phenoxyethanol, within 3 hours, you had complete kill. So you had a 6-log reduction in 3 hours when you combine those two ingredients together, which clearly shows the synergy between those two ingredients. The same thing goes for aspergillus, for mold. 0.1% ethyl-hexyl-glycerin had no effect until out to 168 hours. 0.9% phenoxyethanol, same thing, almost no activity. But when you combine the two, within 24 hours, you had a 6-log reduction. And I want to thank Linda Suttlewitz at Schnittger for this data. In conclusion, the use of multifunctional ingredients can help reduce the amount of conventional preservatives in a formulation and still guarantee efficacy and safety. It also shows that these multifunctional ingredients do have both antimicrobial activity but other benefits when added to a cosmetic emulsion. They're not only preservatives. The next class of compounds I want to talk about are those things considered as preservative potentiators. And many people, when talking about these multifunctionals, I think there's some confusion. And I want to try to set the groundwork between a potentiator, a booster, and a multifunctional. Because in this case, a potentiator is something that will enhance the antimicrobial agent, but does not have activity on its own, but will increase the susceptibility of the microbial cell to that active ingredient. And again, this came out of Russell in 1992, this definition. 3 of the ingredients I want to talk about is EDTA, which again has been around for years, butylene glycol, again going back to the 50s, and 1,3-propane-diol, which is a corn-derived polyol which is made by DuPont, Tate & Lyle. EDTA has been used for years. This reference down here below asking about which one is better, Na2 versus Na3 versus Na4, I found in a Society of Industrial Microbiology book, I think dated back to 1954. It was an obscure reference, and it's funny because the chemists always come in asking which one should they use, Na2, Na3, Na4, and clearly the data showed that the Na2 had the best activity, which was also tied to the pH. But basically, it does have activity against gram-negative bacteria, especially Pseudomonas. There are reported cases where it will enhance the activity of EDTA plus other ingredients when tested against fungus, and it will help against developing antimicrobial resistance. From a multifunctional standpoint, it does help in minimizing fragrance oxidation, discoloration or yellowing, and keep a clear solution clear to ensure that there's no precipitation due to metal ion impurities or kicking out. And it works better in an acid pH range. We use it in pretty much every formulation that we have to protect against Pseudomonas. Butylene glycol, like I said before, has been used since the 50s. It's been used to help stabilize emulsions. It's worked in combination with parabens and phenoxyethanol to keep them into the water phase to help potentiate activity against bacteria. On its own, I've seen reports up to 50% butylene glycol does not have antimicrobial activity. It does have static activity, but it's not a biocide on its own, and it will help minimize the loss of fragrance over time. The most recent one is Zimea-propane-diol, and there's many benefits to this raw material. It's being produced by DuPont, Tate & Lyle, a joint venture out of Wilmington, Delaware. It's a fermentation product, comes from corn. It's a natural derived corn derivative. It does have humectant activity. It can be used as an emulsifier and a preservative booster. and it does have both antimicrobial and antibacterial testing. When tested against the CTFA challenge test, which is a 28-day challenge against the 5 different bacterial pools, it does show complete kill when tested against the Zimea at 100%. And when compared to propylene and butylene glycol, it has the same degree of activity. But again, that's neat, that's at 100%. The benefit here is through skin hydration or moisturization, and for us in the cosmetic industry, this is important because that is what we are trying to achieve with many of our emulsions and skin products. And as you can see, when comparing the Zimea propane diol to butylene glycol, to propylene glycol, and the control, the Zimea performed the best as far as moisturization and hydration. So this was a key benefit because here we had a glycol that was a natural substance because it came from corn. It was a fermentation product. It wasn't a phenolic or synthesized, but it had these benefits. Secondly, the other key thing here was they compared the Zimea to propylene glycol. And from a structural standpoint, the propane diol and propylene glycol are basically the same. It's a 1,3 versus a 1,2 bond. But the significance here is, and as you can see by the graph, and I know it might be a little cloudy, and I apologize for that, but as you can see, when you compared in an RIPT, which measures irritation on the skin, it's a 6-week study, that when you compared 25% of propylene glycol to 25% Zimea, 8.2% of the population had an adverse reaction. When you increased it to 50% propylene glycol, 21% of the population had a reaction, had a stinging or redness versus the 50% Zimea. And when you got up to 75% propylene glycol, 22% of the population had an adverse reaction versus Zimea. So for us, again, from a skincare company standpoint, because it does not elicit an adverse reaction, it does have antimicrobial activity or a synergy there, and also delivers a moisturization effect. This is a key ingredient for the cosmetic industry, and it would be clearly considered a multifunctional. So in conclusion for this part of the talk, the use of these ingredients as preservative potentiators can not only improve the efficacy of our conventional preservative system, but they also improve the overall safety, again, by reducing adverse reactions, not eliciting a positive reaction. So there is a complete package here when looking at these types of raw materials. And there are others out there. I'm just highlighting these 2 or 3. The last section here is to talk about packaging and the role that packaging plays in product protection. Because if you can minimize contact between the consumer, between the environment, and your product, then there's no chance that the mold that might be in the air, or the bacteria that might be in the air, or the bacteria that might be on a woman's fingers, or man's fingers for that matter, cannot come in contact with that product. Many times you've seen with a shampoo bottle, people are trying to unscrew the top. They add some water to try to get that last couple of drops out of that shampoo bottle. So if you can crimp that neck to ensure that top does not come off, then you can fill it under the best conditions. That product will stay sterile for the life of the product. This applies to both storage conditions and finished goods. If you can fill that product during the manufacturing stage into a container which does not come in contact with the environment, with the air, again, it'll stay sterile as long as it stays within that package. And to do that, especially during manufacturing and production, you have to make sure that you're using sanitary and sterile procedures and follow all possible GMPs. If we compared risk factors to the final packaging, we would consider pumps, ophthalmic tip tubes, tubes with one-way valves as low risk because you're minimizing the contact between the consumer and that product. There's if there were bacteria on a person's fingers, there's no way with an ophthalmic tip tube or with a one-way valve that product would the bacteria or the air would get sucked back into that tube and possibly contaminate that product. For a moderate potential risk, tubes, bottles, flow-through pens, those things where the orifice at the end of that package is small, it minimizes the chance of contamination. For those of you who don't know what a flow-through pen is, they are like a lipstick case with a sponge tip applicator or a brush on the end, where you're basically driving that product into that tip and then applying it onto the skin. When you have these flow-through pens with sponge tip applicators, with the sponge itself, then you are creating an environment with the small orifices on that package where there is a potential for bacteria to grow. And the highest risk would be a wide orifice jar, a 4-ounce jar, or a sponge tip applicator, because again, with a sponge tip, you are transferring any bacteria that might be on a person's face back onto that sponge, and those pores are creating a good environment where moisture, bacteria, the sebum or the oils from a person's face in combination with the bacteria, it's just a perfect environment for bacteria to grow. So that's where packaging, can play a major role in ensuring product safety throughout the life of the product. I spoke early on about the ISO guidelines, and ISO 11930, which was published a couple years ago, the evaluation of antimicrobial protection of a cosmetic product. It combines the risk assessment with a challenge test criteria or a challenge test method and a challenge test criteria. The key here is that with this criteria, you are using the final stage is to use packaging as the final pass-fail criteria. Even if you had a product that did not pass the challenge, if you can show that in the package that it was being sold in, that the risk to the consumer was minimal, then it would get a passing grade. And this is the only method that I know of where packaging plays a major role in the overall criteria and release criteria for a product. So again, if you want to look at the interaction between packaging and risk assessment and preservation, this would be a good reference for you. When we talked about the physiochemical factors, I want to reference the ISO 29621, where the physiochemical factors play a major role in determining if a product is a low-risk formulation. And when I say low risk, there are many of these which do not require any testing or do not require preservation. And a good example of that would be a lipstick product, because more often than not, it's manufactured and filled at very high temperatures, 85°C. It's all waxes and oils. There is no water there, and any bacteria that may have accumulated, transferred from your lips onto the lipstick would not grow because there's no place for the bugs to hide. They would only live and survive on the outside of that lipstick, and only survive if there was moisture. And once that moisture dried up, then those bacteria would die off. So for those types of products, the lipsticks, high pH products, high alcohol products, we consider them exempt from testing. So they do not require preservation. They may require minimal testing. And again, the physiochemical factors play a major role in determining which are tested and which are not tested. So this might be a reference you may want to look at. So to conclude my talk, product protection is a multifaceted approach to ensure long-term quality and stability of a cosmetic product. It is basically comes mostly from preservation, but because of the scrutiny of preservation, we've had to find other means of trying to preserve and ensure the stability and safety of our products. preservatives are facing major scrutiny around the world, and that goes for the cosmetic industry, pharmaceutical industry, the paint industry. We're all in the same boat because of, in many cases, because of public perception, because people, read an article, read on the internet that a certain class of chemicals are bad, and then they see that on the label that this product contains that class of preservatives, and therefore they don't buy it, or they say, oh, I can't buy this because it has X, Y, Z in there, and it's gonna cause a problem. And I keep on saying to people is, well, what would be the alternative? As I've shown that for a product that is under-preserved, there is that high chance of bacterial or fungal growth. So there's a trade-off between preservation and potential adverse reactions due to an eye infection because something is not properly preserved. So it really is a balance. That the use of multifunctional ingredients has increased as a mainstream form of product protection. And they should not be classified as conventional preservatives because, as I've shown, many of these clearly do have many different attributes to their chemistries. And both packaging and physicochemical properties can play a major role in the overall protection of a product. So, as I stated, it is a multifaceted approach, and we have to start thinking outside the box. We have to continue to defend those molecules we have available to us. We have to look for new molecules. We have to ensure that the message that we get, that the message that is sent to the consumer is one of sound science and in defense of preservatives, that they are not as bad as some of the people on the internet might think they are and the word that's being spread. And we, the industry, have to keep on continuing to defend not just a class of, or a chemistry, a class of products, but we have to defend preservatives as a whole because we're here to defend the safety of not only the industry, but also the consumer that's buying our products. Are there any questions? Okay, I see it now. The question is, would you please comment on the outlook for probiotics, enzymes, and other natural fermentation products to be used for preservatives functions in future formulations? And are these class ingredients being added to EU positive lists? We have done a lot of work with probiotics here. We've done a lot of work with lactobacillus. We have seen some activity, but it's not a broad spectrum activity. It's very limited. You have to remember that cosmetics are very complex. Many formulations may have 25, 30 different raw materials in them. And to use something like a probiotic or the lactic acid or some of the small molecules that are being produced through probiotics, they would probably be bound up by some of the chemicals that are in those formulations. So I don't see them as a means of preservation. Enzymes, on the other hand, there are a few that I know of that are working very well. There's the lactoperoxidase glucosidase system, which is a very good antimicrobial, which is being used right now in the cosmetic industry. I don't know any other enzymes that are being used by the industry. There is some food-grade enzymes that we've looked at, but again, many of those food-grade enzymes are used as static activity. They're not cytal. So they're used in the food industry to keep bacteria in check, not to kill them off. We've looked at a few, like the niacin, and again, it did not perform. It may perform well in a single matrix system, like a food, but in a complex matrix like cosmetics, it would probably easily get bound up by one of the ingredients in that formulation. The EU positive list, it's very difficult. That's why there's people aren't going out looking for new antimicrobials. To do the safety testing, to do the tox testing on a new antimicrobial or new preservative is very expensive, and to recoup your costs, we just don't know if a company would be able to recoup their investment. But we are working with the industry.
Okay, this is Bob Willard again. dropped off the call briefly, but I just want to say one thing. If there's any question about how to submit questions, click on the Q&A button in the lower left of the presentation window and type your question or comment into the box that appears on the screen. Our next question is from Dhruv Sharan Virdi at University of Delhi's South Campus. This question is, do you think some of these preservatives may augment the development of antibiotic resistance in microbes? Any data on this?
Yes, we, the industry, again, the difference between preservatives and antimicrobial or antibiotic resistance, they work on different mechanisms of action. Preservatives mostly work on a broad approach onto the cell membrane, where antibiotics will work on just a single target within the cell membrane. So the ability for bacteria to develop a resistance to a preservative, I know work has been done in the past, and we've just not seen it. We've looked at, and when I say we, the industry, not me, the Estee Lauder. It does not happen, again, because of that multifaceted approach on the cell membrane. So it's really not a concern of ours.
Okay, thank you, Stephen. Next question from Usha Gandhi, the Dow Chemical Company. Do the flour and other extracts have true preservative activity, or is it just a hype?
You know, it's funny because when you go to, they probably do have preservative activity. You know, when you go to the ASM meeting, when you go to the American Society of Microbiology meeting, and you see these posters where people have found, you know, certain extracts that have antimicrobial activity, and they've done work in their lab to show kill. You know, in a test tube, in a petri dish, it probably works very well. But again, like I said, once you take that extract and you put it into a cosmetic formulation, all of that activity gets lost because of the complex emulsions that we have in cosmetics. They may work well in a water system or in a broth system or in a single dimensional system, but once you get into a complex matrix like a cosmetic product or a pharmaceutical product, then all that activity gets bound by one of those ingredients. You know, it goes in the same thing with natural preservation. People talk about natural preservatives. I don't know of any natural preservatives because everything at some point in time has to be synthesized at a large scale. They may be nature identical. People can say that parabens are natural. Yes, you can find parabens out in the environment. But those chemicals that we're using in the industry today, they are synthetic. They are manufactured on large scale in a chemical plant someplace in the world. So there truly are no natural preservatives. That is hype. Bob?
Well, thank you. Yes, thank you, Stephen. And if there are no more questions, we can wait 1 minute here to see if there are any more questions. If there are no more questions, I would like to once again thank Stephen for his presentation. And Stephen, do you have any final comments you'd like to make?
I just, you know, for those of you who are in the industry, who are in the cosmetic industry, I tell people to be careful of you know, making the preservative-free claim. Be careful of criticizing other people's preservatives, or if you hear that, you know, a preservative has a bad rap or has negative press against it, I recommend that you go in the literature and see if you can substantiate and confirm that activity. And I don't mean through the internet. I mean through a true scientific, you know, Journal of Toxicology, contact dermatitis, you know, noted references that would validate those preservatives and their safety profiles.
Well, Stephen, another question has come in from Lillian Gomez, and the question is, which factor of a multifaceted approach to improve the preservative activity could maintain physiochemical and immune properties of the skin.
Pretty much the pH. I mean, that's one thing that you can control the best. If you can keep the pH of your products down on the acid side, then you can really then balance out the level and type of preservative that you may need for your formulation. And again, if you keep it on the low side, you are in balance with the physiological pH of the skin, which is around 6.2. So if you can keep in the 5.5 to 6 range, one, you are benefiting your emulsion because at that pH range, bacteria have a hard time for growing, and you'd only have to worry about yeast and mold. And two, it'd be more compatible with the microflora of your skin.
Okay. Well, once again, Stephen, thank you for that. It was great talk, and we really appreciate it. I'd also like to thank the audience for participating today. And before we sign off, I'd like to announce that today's webcast will be available for on-demand viewing through February 2016. You will receive an email from LabRoots alerting you when this webcast will be available for replay. We invite you to forward that announcement to your colleagues who may have missed today's live event. Once again, thank you very much, and we'll see you next time. Goodbye.
Thank you.